Okay, so let's have a look at this unit, which is threat analysis. So the key objectives of this unit are to understand the basic steps that an intruder might take for an intrusion, to give a background in the usage of vulnerability scanning, to outline some key current threats and their operation, and to provide some practical skills in vulnerability analysis. Okay, so the first thing that we're going to look at is penetration testing. With that, we use some tools to be able to see if there are vulnerabilities inside an organizational infrastructure. So there's some definitions that we have here. So a white hat is often seen as a good, ethical hacker, whereas a black hat is someone who has malicious intent. Someone who is good and bad is seen as a grey hat, and a blue hat is someone who does testing for software bugs. Some of the people who might be involved in malicious activities include a hacktivist who has a political agenda, a whacker who focuses on wireless LANs, a phreaker who hacks telephone systems, a software cracker who tries to reverse engineer software applications, script kiddies who often don't have a great deal of skills and who use standard scripting tools, and then there are crackers who are motivated by financial gain and have a criminal intent. So often we define a target of evaluation, and it's up to the white hat to evaluate the system for its vulnerabilities. So this could be in terms of white box evaluation, and that is where we know the complete workings of the target of interest and can obviously craft an evaluation strategy based on that. There is grey box, where we have a partial knowledge of the target of evaluation, and we have black box, where there is no knowledge of the actual target of evaluation. So some of the key objectives and terms that we have is risk, which is the likelihood of an occurrence of something that could cause harm, loss or damage. There's a threat, which is something that could harm, cause loss or damage. There's an asset, is something that the organization owns. A vulnerability is a weakness in a system, and an exploit is an entity that takes advantage of a weakness in a system. So for this evaluation, we have an evaluator which will often send data packets into the target of evaluation. Some evaluation software that we can use includes Nmap, HPing and Nessus, and we'll see some examples of these later on. So a key thing that we need is to have a code of ethics, and a good code of ethics is defined as not to exceed the authorization limits, to be ethical in everything done, and to limit the possible damage while maintaining confidentiality. So there's often three main levels of testing. The first one is a high-level test, and there is no hands-on test done here. This is often looking at schematics, documentation, previous logs and so on. Then at level 2 there's a network evaluation, which typically involves information gathering, scanning and vulnerability assessment. And then finally we might have a level of penetration testing, which involves taking an adversarial role. So some of the things that the white hat might focus on is social engineering, stolen equipment attack, physical entry attack, and insider attack, and also outsider attacks. And some of the key skills involved include the configuration of routers, firewalls, Windows operating system, network protocols, and so on. So the one key focus is on the CIA principle. C stands for confidentiality, where only authorized entities can access sensitive data, and that includes locked doors, defenses, firewalls, passwords, encryption, VPN access, and so on, to keep the data private. Then we have integrity, and that focuses on changes of data by unauthorized entities is detected, and also authorized entities can only change sensitive data. And then we have availability, where only authorized entities have continual access to the data. For this we can have mirror servers and failover equipment. For integrity we can have access control, Windows file protection, checksums, and network operating systems. So why? Well, there are many audit compliance regimes, and these outline some of the key audit compliance regulations. In the US, we have Sarbanes-Oxley's, which relates to transparent accounting and reporting of companies. We have the Patriot Act, which allows the government to monitor hackers without a warranty. And we have other ones such as the Computer Fraud and Abuse Act. In healthcare we have HIPAA, and so on. So the key thing before any testing occurs is that there's written or permission from the organisation. Then there's a scope definition, the assessment is performed, and then the final stage is the post-assessment activities such as documentation and meetings with the organisation. Okay, so a key feature in any system is not to allow an intruder to get to a profit stage. So we need to be able to detect the initial stages of an intrusion. And typically we'll see a standard set of activities before an intruder gets to a profit stage. So this might involve outside reconnaissance, looking up DNS records, IP information. Then there could be some inside reconnaissance, such as looking at the sub-network layout, where network devices are, and so on. Then to find an exploit, such as a weak password or breaching a firewall. From here, the intruder can gain a foothold onto the system and possibly advance up the levels of privilege, and then finally onto the profit stage. So if possible, we want to be able to detect at an early stage of these activities, such as when there is an inside reconnaissance or when there's a probing for an exploit. So typical signs of malicious activity include TCP UDP scans, and with this an intruder would scan a host for open TCP and UDP ports. So we can see in this case, try to open port 10, port 11, port 8888, and so on. And each host typically has ports that it's listening on, and the intruder can possibly find points of connection to the host through these ports. So nstat -a will be able to tell us which ports are actually open. Another sign of surveillance is a ping sweep, where an intruder will sweep the computers on a network to see which ones are alive or not. And then we can have an intruder probing for a weak password, and in this case the intruder sends in logins for different usernames and passwords. This is known as an account scan. Problems that we can have here is anonymous logins, the same password as the user's ID, a password of password, using login, using system default logins, weak passwords, well-known passwords, and also social engineering, where an intruder might actually try and approach a user and ask them for their password. Okay, so if an organization wants to be safe from external and internal threats, then sometimes they need to perform a vulnerability analysis to make sure that their systems are watertight. So certain organizations publish these vulnerabilities on a regular basis, such as for US CERT, and they have numbers, a vulnerability note number, and publish them on a website. So in this case we have a vulnerability number, gives a basic overview of it, a description of it, the impact, a solution, and then the systems that are actually affected. So it's important for organizations to keep up to date with these things and hopefully to patch their systems so that they are not exposed to external threats. The Nessus database is another useful source, and we have a CVE ID for this. So you can see that in this case we have a vulnerability for Microsoft Internet Explorer for a cross-scripting attack. Defines when it's published and also the severity level. One set of tools that we can use to scan a system for vulnerabilities is Nessus, and this shows an example here with Nessus. What we do is we define a policy, we then create an instance of the policy, run it, and then we get a report back. So in this case we can see the policy is to do a port scan, we'll do a TCP scan, ping the hosts, and so on. So we can create our policies and then an instance of it and then run it. So let's look at a demo of this, of Nessus. Okay, what we have here is a virtual image of Windows Server 2008, and we can see here the address is 192.168.75.130. This is a private address, so our scanning through Nessus will be done with inside the virtual image, and what we'll do is we'll actually have a look to see which ports that we've actually got open. So we can see in this case the ports where we have something listening. It's port 23, so we have a telnet server. So let's see if we can just prove that that port actually exists. So on our normal machine, what we'll do is we'll just try and telnet in to that address 168, and our address is 75.130. You can see here that we have a telnet connection, so that's working okay. We should also have a web server running from that address, and we go to 192.168.75.130, and there we see we have a web server running on here. Okay, so this virtual image is giving us a telnet port and also a web service. So what we'll do now is that we'll go to Nessus, if we can find it. Sorry, I've just stopped it. So what we'll do is we'll just run it now. So Nessus, the Nessus scanner allows us to use a web browser to connect and do a vulnerability scan. And so I've created a user here, and we just log in. I'll just delete these reports that we've created earlier. Right, so what we'll do is we'll define a policy. So in this case we can add a policy, but there's a policy already created, and we'll just have a look at that policy. You can see here that says port scan. It's going to use a TCP scan, and we'll just accept all the defaults there. There are other credentials that we can use and various plugins, but we'll just do a generic TCP scan just now. So then what we do is we just add our scan here, and we'll call it my scan, and this should show you all the policies that we have. And we're going to scan our virtual image here. So our virtual image is at this address, 192.168.75, 192.168.75.130, and we'll just launch that as a scan. So it'll take some time for the scan to complete. So it's just running just now, and we can have a look at how it's getting on. Just takes a little minute to do the scan. So this is the virtual image here, and this is our local host, and we can see here it's now running, and it's already discovered port 139, port 445, and so on. So as it goes through, it should hopefully discover the other ports that are open. And we can see a few more coming through here. Just have a look over here to see if it's getting the right ports. And the ports it should discover are 2380, 135, 137, 445. So we can see here that it's getting these correct. This is showing us the current connections that we have. So we can now have a look at each of the ports in some detail. So you can see here that we can use Nessus to actually scan our hosts. Another method we can use is to use Nmap. Okay, so these are some of the options that we can actually use. So we'll do Nmap verbose, and we want to scan 192.168.75.130. And we can see here that Nmap has found port 139, that's port 80. So the main services that are open are Telnet, HTTP, MSRPC, and so on. Another vulnerability testing tool that we can use is Nmap. And Nmap allows us to scan an external host for the ports that it has open, its operating system, and so on. So we can see in this case Nmap has scanned a number of ports, and then we've used Snort in this case to be able to detect the scanning. And the preprocessor that we use within Snort is FS port scan. We run Snort, and then that is able to then detect the scan. Okay, so let's look at a demo of this. So in this example we're going to use Snort to detect a ping from another host. So what we'll do is we'll just start up Snort here with inside the virtual image. Okay, so we've created some rules here that are pre-prepared. So initially what we'll do is that we'll just detect a ping. So this detects ICMP on any incoming connection. So we'll save that. Just have a look at our rules. Okay, so we have alert ICMP from any network to any other network. So then we'll start up Snort, and so we can see here it has written the rules file, and it has one rule to detect, and it's now listening. So the IP address that we have here with inside the virtual image is 192.168.75.132. Okay, so we've asked it to log to the build folder, and we can see here that our alert.ids file now has some alerts in it, and there's the content. So you can see here it's picked up the original ping as echo, so it's picked up 1, 2, 3, 4. 4 echoes, which corresponds to the 4 pings that we actually sent. Okay, and we can see here when we quit Snort, then we see 4 alerts. Now what we'll do is that we'll try to scan the ports on the machine to see if there's any vulnerabilities. So we'll open up our rules file again. And in this case we'll bring our preprocessor rule in and take our ping rule out. So in this case we have a high sensitivity FS port scan, which is a preprocessor that will be able to detect a port sweep. So just make sure that our rule is set, and that's fine. So we'll now start Snort again, and then over here we'll run nmap, scan for the operating system 192.168.75.132. Just take a little minute to scan. Obviously it runs slower because we're in a virtual image, but we can see here there are many ports open on our virtual image. And then hopefully over here we now see that port scan has something in it. So we can see here the scan that we've run was over here from 75.1, and this is our machine here with inside the virtual image, and we can see here that it scanned from port 7 up to port 61,900. Okay, so that shows an example of the ICMP rule, and also for the actual port scan. Okay, so if we're ever struggling to know which port that we want to receive on, we just snort minus big W. You can see here, this is the connection here that we're listening on. Okay, so let's look at some current threats, and one of the most difficult to protect against are botnets. And with a botnet, what we have is a botnet master, and then a number of botnet agents. So these botnet agents are controlled by the botnet master, so they can call back, speak to the botnet master, and the botnet master can send them a command, such as to infect other hosts or to activate them. And so this is defined as control by proxy. And a basic taxonomy of the botnets defines their basic characteristics. So we have obviously the attacking behavior of the bot. So this could be such as sending a SYN floods for a distributed denial of service, or could be for identity theft. So the bot could steal usernames and passwords, or it could attack other systems from the infected host. We can have the command and control structure, and this is the method that the botnet master uses to control the bot slaves. Could be a centralized model, such as using where bots contact a single botnet master, or could be on a peer-to-peer based command and control, or could even be a random one. We have rallying mechanisms, and with this we define the way in which the botnet slaves rally around the botnet master. So this could be a hard-coded IP address where the bots actually know which IP address to contact. It could be through the dynamic DNS domain name, or it could be a distributed DNS service. The communication protocols that they use is obviously important as to how they communicate between the bot and the botnet master. It's important that we set up mechanisms to be able to detect this type of activity. Typically in the past it's been an IRC channel where bots subscribed to the IRC channel, but often these days IRC is banned on organizational networks. So increasingly they're moving towards peer-to-peer methods and HTTP because they can typically get through the firewall. Could also be instant messenger and so on. Then we have the evasion methods. So this might relate to them being encrypted or obfuscated in some way. They might communicate through IPv6 tunneling or even voice over IP tunneling. And then we also have other observable activities which might relate to how they run on the host, such as what files they copy and use, which threads they create, and what the network trace looks like. So for us it's important that we can actually characterize our botnet to be able to detect its operation, either in its attacking behavior, its evasion method, other observable activities, rallying, and also its command and control. So with a botnet, what we can have is a crime such as this could occur, where someone is redirected to a fake bank login. Then the details of the login is taken and sent to a botnet master. That botnet master finds a botnet inside the country that the bank is based, and the botnet is then given a command to withdraw the money, after which the money transfer is made and the remote criminal gang can actually profit from this. So it's a worrying threat in that botnets could be dormant on many machines waiting to be awoken by the botnet master. Some research done recently on the Torpig, the Torpig botnet identified that there was the study over 10 days in 2009 by the Department of Computer Science in the University of California actually found there was 180,000 infections for Torpig, which gathered over 70 gigabytes of data. So this included over 1.2 million IP addresses and the credentials of the financial logins for over 8,310 user accounts. Another particularly difficult current threat is phishing. So with phishing, an external intruder will often phish for user data. So in this case, we can see here we have a perfectly valid looking email that's sent, but unfortunately it's fairly easy to spoof email addresses. So in this case we have a spoofed email address. The other thing is that this is a graphic which looks rather strange, and it's obvious that the intruder is sending it through the spam checker, so the spam checker can't really read the text with inside the graphic. Along with this, when we move our cursor over the message, we can see here that the actual link that is being sent is an IP address on a strange looking port, where this is the link that's shown, but when it's clicked on it goes to this other link. When we do a lookup, we actually find that it doesn't resolve to the domain that we're actually looking for. So we can see this as an example of a trapdoor. When we look at the details of the message, we can actually see that the email itself came from a non-verified source, and also looks at a strange domain to send the email from. Increasingly there's a move towards pressurized phishing, and with pressurized phishing the user is sent a message which puts some pressure on the user to act instantly. So in this case we can see that a message has been crafted in which the user is being prompted to reply as quick as possible, or there will be left bad feedback on eBay. So some users will be tricked with this into thinking that it's a valid looking email, so everything looks fine here. It looks like it's from member@ebay.co.uk, but when the recipient clicks here, then their details won't go to eBay but will go to the intruder. You can see a problem that we have here in that the actual login goes again not to this URL but to another external one. Same again with this. We can see here that there is a request for that someone has changed the password, and the user has been prompted to click on the link to resolve this, and unfortunately once they do this then it will go off to a malicious site. Okay, so we can have problems like this, where there is a response required. When we actually look at our HTML for this email, we actually find that clicking on this button sends the user's details to a malicious script, which is obviously being used to gather these phishing details. And more we see examples of complete sites being copied, so that it's very difficult for a user to tell that it isn't a valid one. So in this case we can see here all the graphics, all the tabs and so on have actually been taken from the real site, but this is a malicious link. So what to look for? Basically, when there is an email which requests a username and password, this is highly unlikely to happen from a valid business. When there's graphics which are used to display the text, often there will be poorly laid out graphics content and an IP address with inside a web link. Also, we should look for a domain on the web which differs from the sending domain for any links, where there are graphics content taken from an external site from within inside an email, and worryingly when iframes are used with inside HTML content. With iframes, what we get is a single tag called an iframe tag, and with this the intruder can bury an external site, the content of an external site, with inside a valid looking page. So in this case, this content here is taken from an external site and then buried with inside this page. So an iframe is a particular worry in that we may think we're accessing a certain site, but an intruder may have buried information into it from another site. Another threat which is current is related to active attacks, and an example of this is with an SQL injection attack. In this case, what we can see is that a parameter is used to get data through a URL and into the program. In this case, we have a variable called test, which is meant to be used to pass information, but what's actually happened is that this SQL information has not been filtered and has went straight down to the database. So when it's passed to the database, then the actual SQL query looks something like this: select star from DB1. In this case, we can see here that this shows the database. So what we'll do is we'll have a look at an example of SQL injection. Okay, so what we're going to see here is an example of cross-scripting with an example of an SQL injection. So we've set up an ASPX page here. It's a fairly simple page. It basically just has a data grid and is bound to a database. Just takes a little minute. We have a virtual image here that we're going to modify, so we can get the IP address of the actual virtual image. So it's 75.132. So we're going to contact this image from our desktop. Okay, so we have a data grid here, and then we've associated page load, and so in this case we've created an SQL database, and the table is DB1, of which there is a first name, surname, test1 and test2. So the connection to the database is made here. So it's Napier is the image and SQL Express, and that creates our SQL connection. The database that we've created is called sample. So in the first case, what will happen is that it's a simple SQL command to basically just read from the database. It will then execute that command, and then we bind the results of that to our data grid. So what we'll do is we'll initially contact our server here, 192.168, and we just check to see what the IP address is. So 75.132. So what we should see is the default homepage, and there it is. So with inside our virtual image, our default website is here, and we have an IIS stat.html. The files that we've created are here, and it's called databasesample.aspx. So the first program is called databasesample.aspx. So you can see here that this has contacted our virtual image and given us our database reading. So we can see there's 5 rows in the table. So what we'll do now is we'll now check out our insert command just to see if it works. So what we're doing here is that we're creating a new row within inside our table, and this is an example of an insert row. And so we'll give Fred Smith 3, 15, 25 and 35. So insert into our table these values. Okay, so we'll just save that, and now what we'll do is we'll just run it again, and we don't actually see anything because we haven't done a select. So we'll bring that command back in and we'll save, and now when we look again, our database has been updated with our new row. Now what we'll do is we'll bring in a check for the parameter. So in this case it does a query on the pass parameters within inside the URL string. So in this case it will look for the word test. So now we'll bring in back this one. So if there are parameters passed, then it will feed the parameter into the actual page as an SQL command. So what we'll do now is we will do our SQL injection here. Okay, so we go back over here, and to pass parameters we'll say test is equal to, and so now this will take the value of test, feed it into the string, and then that will become the command. So you can see here that it's actually done the same thing. Now what we'll do is we'll insert another command just that we've proven, so just to make sure that we are actually getting the right command coming through, what we'll do is that we shall just modify this. Yep. So you can see here, if we run it again, let me just save it. Run it again. I can see it shown in the table. So this means that this command, the 20s are spaces, this command here has been inserted directly into the program, into the page, and then it's performed a search. It's went straight through to the database. So now what we'll do is just to show that it's possible, is that we'll add another row, and we'll just take that out, and we'll take this, and this will now become our new SQL. Okay, so all that should happen here is I'll take the value of test, we've commented out the insert row. If you go back here, okay, so we get an error because we haven't typed it right. It gives us that, so now do that. Okay, so that we can then go and actually get our database back, and we can see here this was the row that we actually added. And that shows an example of the SQL injection. Another threat that we can have is inference. With inference we have some data, and certain accesses to the data are barred, but unfortunately there can be ways that an intruder can infer information from different queries on a database. Okay, so let's take an example. So in this case we are disallowed from summing up the ages of all the users on a database, but unfortunately the query that's allowed to go through is where the gender is male. We do a sum of the ages, and then we do the same again for female, and when added together we actually get the query which was not allowed, which is the sum of the ages. Okay, so let's have a look at this. Okay, so there's our table here, and what we'll do is we'll make an SQL query. We just have a look at this as a query. Okay, so first we'll do is we'll search for the sum of the ages, so that's age here, on the address table where the gender is female. So we can see that's 60, and now what we'll do is we'll do the same query. This time we'll make this male and run the same query again, and it's 100, so it's 160 is the total age. And we can see here that that is the same as the sum of all the ages on the database. Another way that an intruder might actually infer information is to run a direct attack, and this is where the intruder actually hides a query within a bogus condition. So we can see in this case that the intruder is trying to find out the address of Bob, but possibly that query is not allowed. But in this case, then this condition will always be false, with ages less than 30 and the age is greater than 30 is a non-valid condition. So this should only show the address of Bob, because this condition will always be false. So if we run this SQL query, we can see here that we get Bob's address. Okay, so we get this condition. If an intruder is barred from getting a number of rows, then often what they can do is use the same technique as before. So in this case, the user returns all the names for females. Okay, so we get Bob and Eve, and then can do the same again for male, and we run that again, and we can see here that the intruder now has all the names on the database. One method that can be used to increase the security on the database is to use polyinstantiation, and with this we actually create two records for one record that we're trying to protect. So in this case we have a low security version where the date of birth in this case is not entered. We also have the same record for the same person with a high security version. So someone accessing with low security will see the database with this record in it. Someone who accesses with a high security will see this record, and this way we can keep the two levels separate. Okay, so we can also have traces of activity on a machine that relates to network traffic. And if we have a Windows machine, there are certain folders that are set up that will monitor and keep a history of various activities. So in the recents folder we see any recent files that have been created. Within cookies we get a store of the cookies, so if a web page is accessed, if it has a cookie, then it will save it in the cookies folder. We can see Internet Explorer history inside this folder, and also this one, and there are various other ones such as the start menu and documents and so on. These are reserved as special folders. So we have a look at our toolkit. So we can actually look at the previous history of URLs. Again, this is stored inside the URL history folder. There are a number of special folders that we might look at in terms of an investigation. So we can have the recent folders. We can look at the cookies. So in this case there's quite a few cookies in here. So it just takes a while to scan the folder. Then we can have application data, desktop, favorites, history, the internet cache, documents, pictures, and so on. There can also be hidden folders on on a system. So you can see in this case there is a hidden file here. So when we do a normal listing, the file might not appear, but only when we do a search for hidden folders and files do we actually see them. And you can look at the file rights for each of our files and folders. Okay, so that concludes the presentation. So hopefully it's given you an understanding of some of the methodologies that we might use in investigating network traffic, a deeper understanding of some of the key protocols such as IP, TCP, ARP, ICMP, DNS, and a few application layer protocols. And we've also investigated some basic audit sources to determine network activity. Okay, so let's look at one of the vulnerability tests that we can actually run. So what we have is a Linux image here, and we should find that in here we have a few services running. So the services that we have running in the Linux image include FTP, Telnet, Web, and so on. And then what we're going to do is run Hydra from the Windows image. So we'll just find the Hydra folder first. Here we are. So we have Hydra here. And then what we're going to do is that we're going to run a Hydra vulnerability test from the Windows image into the Linux image. So we'll just find out what the interface address is, and it's 75.137. Okay, so it's 192.168.75.137. Okay, so we'll just run nmap to see if we can see the services that are running within inside the Linux image. And while we're doing that, we'll just run Hydra over here. So Hydra itself can actually investigate a wide range of protocols, and here are some here. So we have the service, where the service itself can be Telnet, FTP, and POP. So what we'll do is that we'll do a scan of the FTP server. So we can see here that a scan has shown that it's a Linux image, and then it has FTP open. So what we'll do is we'll scan for the usernames and passwords within inside this. Okay, so what we have is that we have a file called login.txt, and I've just added a few different user IDs: admin, test, test1, and Napier. And we've created a password file, anon, Napier, Fred, none, password, and Napier 123. Obviously in a real life situation there would be thousands of user IDs and passwords in here. Okay, so we're going to run Hydra. The -l defines the user ID file, -p defines the password file. This is the address that we're going to scan, and we're going to scan for the FTP protocol. Okay, so it's now scanning. It just takes a little minute. So what it's doing here is to go through each of the passwords, and we can see here it's actually found the login name and the password. So if we wanted, we could show it in a verbose format, where it will actually show us the usernames and the passwords that it's actually testing. So we can see here it tries each of our user IDs followed by the password. So in this way we can actually investigate our systems to see if they are vulnerable to attack. We can try the same for Telnet. We can see here it's trying a few, and again it's actually found out the login name and the password. So if we wanted, we could run Wireshark to have a look at the footprint, because obviously what we want to do is to use something like Hydra to be able to see our vulnerabilities, but we also need to see if someone is actually scanning our network. So we'll run Wireshark here. And not in the Linux image. Just takes a little minute to start up. It's also running slightly slow because it's in a virtual image. Okay, so there are many options that we can use with Hydra, such as defining a different port if it's not on a standard default port. As we can see, FTP ran on port 21, Telnet on port 23, but if there are servers running on other ports, then we can scan them too. Okay, so we'll just capture from here. Seeing some background traffic coming in. Okay, so we'll now run our Hydra attack again, and we can see here this is the trace that we get. So you can see lots of incoming requests. And the ones we're interested in are up here. So we can see here this is where we're getting the communications between the two devices. So for example, we have a look. So this is where it's asking for a password, and then this is the password being passed, which is none. There's the password Fred, and we can see now it goes on to user test. It's asking for a password for test, then it's passing password user test 1, password required for test 1, and then anon, and so on. So eventually what we should see is a successful login for the user, and that happens. You can see here these are unsuccessful logins, login and incorrect. So eventually we should see a login correct. If we just keep going down, obviously we can search for this if we want. Sending messages back here showing that it wasn't successful. Again, login incorrect. Should find it eventually with login incorrect. Login correct. So we can see it happens somewhere around here. We can obviously watch our stream. So here's an example here of user admin, password Fred, user Napier, password anon. Okay, so that is the end of the threat analysis unit. So hopefully you will have a better understanding of the basic steps that an intruder takes to undertake an intrusion, a basic background in the usage of vulnerability scanning from a white hat point of view, we've outlined a few of the current threats, and also provided a basic practical skills in vulnerability analysis.